Okay, here's a derivative problem that involves exponents and radicals and also a quotient. And we're given f of x is 2 times the cube root of x to the fourth minus the sixth root of x divided by the fifth root of x. And we're told to find f prime, or find the derivative. Now when we look at this, we immediately see, a quotient. One thing divided by another, so I could use the quotient rule. So I'm going to have to do the the bottom times the derivative of the top. That's going to be kind of hard. Minus the top times the derivative of the bottom, and then put all of that over the denominator squared, and then try to simplify that. That's going to be a real mess to try to simplify. I can actually make this problem a lot easier by manipulating the original function sum first. I'm going to rewrite the function, and I'm going to rewrite all of these radicals in exponential form. So I'm going to say f of x is equal to this: 2 times x to the 4 thirds, because this 4 here is an exponent, and the cubed root means a denominator of 3 in the exponent. So that's 2 times x to the 4 thirds minus the sixth root of x here is x to the power of 1/6. And then instead of dividing by the fifth root of x, I'm going to multiply the whole thing by the reciprocal of that. And that fifth root of x down here is x to the 1/5. So instead of dividing by x to the 1/5, I'll multiply by x to the negative 1/5. So this is my new function. And now you think, okay, well now it's a product. I have this times this. Maybe I could use the product rule, but that's still a bit of a pain to do. So what I'm going to do is distribute this x to the negative 1/5. I'm going to multiply it by the first term and by the second term, and I'll get a simple power function that I can differentiate pretty easily with the power rule. So let's distribute here. The f of x, I still haven't started taking a derivative. This is f of x, not f prime over here. F of x is going to be 2 times x to the 4 thirds times x to the negative 1/5. And then I'll have minus x to the 1/6 times x to the negative 1/5. Now these can be combined into a single x, and so can these. Okay, over here in this first term, if I say f of x, and this is still the function, not the derivative, 2 x to the 4 thirds times x to the negative 1/5, if I multiply these two exponents together with the same base, I have to add the exponents. So I need to add 4 thirds and negative 1/5. And that's going to be, let's see, 4 thirds is 20 fifteenths, and negative 3/15. That's going to give me 17 fifteenths. Okay, so this is 2 times x to the power of 17 over 15. Then I have minus, and then I need to add the 1/6 and the negative 1/5. Okay, let's do that. 1/6, we'll just say 1/6 minus 1/5. Well, 1/6 is 5/30 minus 6/30 is negative 1/30. So this is x to the negative 1 over 30. And now I can take the derivative. This is just a power function, and so is this. So taking the derivative of that will be a lot easier than doing the quotient rule for this, or even the power rule for this. So let's take the derivative now. F primed of x is going to be 2, my constant multiplier stays out front, then times 17 fifteenths, this exponent just comes out front as a multiplier here, times x to the power of this minus 1. And 17 fifteenths minus 1 is just 2 fifteenths. So it's 2 fifteenths there. And then minus, and then I do the power rule right here. I get negative 1/30 times x to the power of this minus 1. So negative 1/30 minus 1 is going to be negative 31 over 30. And then I'll just simplify this one last step. I'll just get a single number there and take care of these negative signs right here. So my final answer is going to be 34 over 15 x to the power of 2/15 plus 1/30 x to the negative 31/30. And that's the derivative of my original function. And that looks like kind of a messy, difficult, complicated answer, but that's the simplest answer, or the simplest way to write it. And that's a whole lot easier way to get there than trying to go straight to the quotient rule or the product rule.